I'm continuing with some class examples that use the first page of your trig properties notes. In the first page, we were acquainted with reciprocal properties, quotient properties, Pythagorean properties, odd-even properties, and cofunction properties. So here's the first statement. Is this a true statement? Explain how you know. So what you want to do is look on your trig properties and see if this reminds you of anything. And you might see, oh, pi over 2 minus x, that sort of looks like 90 minus theta. Maybe this is a cofunction property. However, if it were a cofunction property, this would have to be sine, and it's not, it's cosine. So what other property is there that would have cosine of something equals cosine of something? Hopefully you recognize your odd-even properties, because odd-even properties say cosine of negative x is equal to cosine of x. So if we can show that these are opposites of each other, then we could show that this property is that this would be a true statement. If we cannot show that these are opposites of each other, it would not be a true statement. So let me just take you over here and think about this. If I have A minus B and I have B minus A, are they opposites of each other? Well, let's take A minus B and multiply it by negative 1. So if I do negative 1 times A minus B, I would get negative A plus B, and if I rearrange that, that would be B plus negative A, which would be B minus A. So A minus B and B minus A are opposites of each other. So I could say here that cosine of pi over 2 minus x is the same thing as saying the cosine of negative x minus pi over 2. Okay, and convince yourself, because negative times x, negative 1 times x would give you negative x, negative 1 times a negative pi over 2 would give you positive pi over 2. And if I have cosine of negative x, the opposite of x minus pi over 2 equals cosine of x minus pi over 2, then I have this relationship going on. Cosine of a negative input equals the cosine of the positive input. So this is true and this is the because it's the using the odd-even properties. And I usually just call these odd-even properties, even though that cosine is an even function, but we call these the odd-even properties. So by the virtue of the odd-even properties, this is a true statement. Okay, let's look at number 6. Use your knowledge of trigonometry and special triangles to find cosine pi over 6, 5 pi over 6, and sine 5 pi over 6. No calculator. Okay, so you could easily do this on the calculator and check yourself, but how would you show me that you could do this without a calculator? So we have to recall a couple of things. We need to know what pi over 6 means. We need to know what 5 pi over 6 means. We need to be able to draw this and find a trig value without a calculator. So let's recall a few things. Let's remember that pi equals 180 degrees. Therefore, pi over 6 is 180 divided by 6, which is 30. Therefore, 5 pi over 6 is 5 times 30, which is 150 degrees. So we're talking about a 150 degree angle, which is in quadrant 2 and has a 30 degree reference angle. So I'm going to draw just a quadrant 2 angle here. Oops, that's not a quadrant 2 angle. Let me undo that. Quadrant 2, I'd like to draw it like this. A 150 degree angle is going to look like this. And in quadrant 2, that means this angle would be a 30 degree reference angle. And using what I know about special triangles, opposite the 30 would be 1, the hypotenuse is 2, and the side that would be opposite the 60 degree angle, which would be up here, would be the square root of 3. Also, since this is in quadrant 2, the x value would be negative. So if I wanted to find sine and cosine of 150 or 5 pi over 6, then sine, and actually I'm going to write this over to the other side because I want to be directly below. So what I found here is that sine of 5 pi over 6 is opposite over hypotenuse over here. Opposite over hypotenuse is 1/2. And that cosine of 5 pi over 6 is adjacent over hypotenuse, which is negative square root of 3 over 2. All right, so now I know what sine of pi over 6 and cosine of 5 pi, sine and cosine of 5 pi over 6 are. So that would be step 1, is find those values. Step 2 then is to show that this is a true statement. So when I see cosine squared of 5 pi over 6, remember that is the same thing as saying cosine of 5 pi over 6 squared. Okay, squaring that whole thing. So that's what I'm doing there. And the same thing with sine. So this is like sine of 5 pi over 6 squared. So when I see this and this, I can substitute the values that I have said they equal, because if these are equal to each other, I can substitute one for the other. So this becomes negative the square root of 3 over 2 squared. Notice the cosine isn't there. I'm not substituting it for 5 pi over 6. I'm substituting it for the whole thing. Sine of 5 pi over 6 becomes 1/2 squared, and that supposed to equal 1. Okay, so I'm going to square both of those. If I square a negative number, it becomes positive, and if I square a square root, the square root of 3 times the square root of 3 just becomes 3. The denominator is 2 times 2, so it's 4. So I have 3/4. 1/2 squared would be 1/4. 3 plus 1/4 equals 4/4, which is 1. So I have shown that that is a true statement. So I would only ask you to do that with no calculator if that was a special angle. So this is a good review of stuff we've done earlier in the semester. So now go down to the next problem, very similar problem, and try it yourself. You might want to pause the video and check it out and then see if you can do it. Okay, so I drew an angle that's equivalent to 315 degrees. Now, how did I know 315 degrees? Well, I know that pi over 4 is 45 degrees, and I know that because pi is 180, pi over 2, which is half of that, would be 90, and pi over 4 is half of pi over 2, it's 1/4, so that would be a 45-degree angle. And if I count 7 45-degree angles, that would be 1, 2, 3, 4, 5, 6, 7. That puts me in the middle of quadrant 4. So this is a 45-degree reference angle. You label the sides of a 45, 45, 90 triangle 1, 1 square root of 2, except this one is negative because we're in the negative y direction. Remember, the hypotenuse is never negative. Secant is the reciprocal of cosine, so it's going to be hypotenuse over adjacent, square root of 2 over 1, which is just square root of 2. Tangent is opposite over adjacent, so tangent of 7 pi over 4 is negative 1 over 1, which is just negative 1. So now I can do my substitutions. So I'm trying to show that this Pythagorean property evaluates correctly. 1 plus tangent squared of the angle equals secant squared of the angle. So 1 plus, now what I'm going to do is substitute my value for tangent of 7 pi over 4 and square it. So my value is negative 1 squared is equal to, now substitute my value for secant, which is square root of 2, and then square that. So this is going to be 1 plus 1 equals 2, and wow, can you do higher math? That is a correct statement.